Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, how are all of you today? Okay, today, right now, in this video, I'm going to continue our discussion of lecture 4, Matrices and System of Linear Equations, with a subtopic of 4.3, Inverse Matrices. Okay, and specifically, we're going to use the adjoint matrix. As far as you're concerned, that when I asked my previous students, they were exposed, they studied or were exposed to inverse matrices with a size of 2 times 2 during your Form 4 and Form 5. Okay, that's what I have, that's what I know. So today we're going to find out the inverse of matrices for matrices of 3 times 3. Okay. Now, at the end of lesson, students should be able to find inverse matrices using adjoint. Okay, that's we call as stated there. Okay, previous in the lecture of part 2, we have learned on how to find the minor. To find the determinant and minor. Okay. Then now we look into the cofactor matrices of A. Adjoint is defined as a transpose of adjoint of matrix A is defined as a transpose of the cofactor matrices that is given here. Okay, this all stated in your lecture notes. Okay, I'm not going to discuss much on this. Remember, we have find the minor and cofactor, where all the minors multiplied with the sign of positive and negative, value of positive and negative. For example, here, the positive comes from the negative 1 to the power of 1 plus 1. Based on that, we call the rows and the column, row number 1 and column number 1. So that, and the minor itself. Okay, so then cofactor is an negative 1 power of I plus j multiplied with a minor. Example, okay, given the matrix of A here, find the adjoint. So this is we call the matrices of A based on the question, and this is what we have learned last time, the minor and cofactor. Okay, now class C11 based on row number 1 and column number 1. So as we discussed on the previous lecture part 2, that we hide or we delete or hide the row number 1, element in row number 1 and element in column number 1. So what you see here now, we got 2, 4, 1, 3. Okay, 2, 4, 1, 3. Then, so we multiply between 2 times 3. 2 times 3 minus 4 times 1. 2 times 3 equal to 6. 6 minus 4 equal to 2. Then, for what we call cofactor of 1, 2. So we delete or hide the element in row number 1. There you go. And column 2. Here. So what can you see here now? We got 3, 4, 1, 3. 3, 4, 1, 3. Then it is 3 times 3 equal to 9 minus 4 times 1 equal to 4. And don't forget that here with negative, so we got negative here. So 9 minus 4 equal to 5. And we got negative 5 here. Next, C13, so we hide element in row number 1 and column 3. Row 1 and column 3. So what we have here now? 3, 2, 1, 1. 3, 2, 1, 1. Okay, so with a sign of positive here, 3 times 1 equal to 3 minus 2 times 1. Okay, so 3 minus 2 equal to 1. Next, C21, cofactor of 2, 1. Now, we hide or delete the element in row 2, 3, 2, 4, and column 1, 1, 3, 1. So I see here now, 2, 3, 1, 3, that's it. 2, 3, 1, 3. So then, multiply 2 times 3 minus 1 times 3. Okay, 3 times 1 or 1 times 3. Supposedly we write as a 3 times 1. Okay, AD minus BC here. Okay, 2 times 3 equal to 6. 6 minus 3 equal to 3. Then next, so cofactor of 2 and 2, we hide the element in row 2 and column 2. There you go. So what's left here now? 1, 3, 1, 3. 1, 3, 1, 3. So then 1 times 3 minus 3 times 1. So 3 minus 3, 0. Cofactor of 2, 3. So we hide the element in row 2 and column 3. There you go. So what's now? 1, 2, 1, 1. Okay, 1, 2, 1, 1. So then, here 1 times 1 minus 2 times 1. So 1 minus 2, negative 1. Our class. I forgot something. In second row, we got negative, positive, and negative. Should be negative here, negative here, and negative 3. Negative, negative, and negative. Here become positive 1. Okay. So, beside this, this is our reference to, we got negative, positive, negative 1, positive 1, negative 1, positive 1, negative 1, positive, negative, positive. Okay, next. To find the cofactor of 3, 1, we hide the element in column 3 and row 1. There you go. So I say here now, 2, 3, 2, 4. 2, 3, 2, 4. Okay. 2 times 4 minus 3 times 2. So then 2 times 4 equal to an 8, 3 times 3 is 6, 8 minus 6 equal to 2. Positive. Next, C32, hide the element in row 3 and column 2. There you go. So then you can see here now what's left then. What is left here now? 1, 3, 3, 4. 1, 3, 3, 4. 1 times 4 minus 3 times 3. Okay, and don't forget we got negative here, so we got negative here and negative. So 1 times 4 equal to 4 minus 9. 4 minus 9 equal to negative 5. Negative 5 times negative, positive 5. Then, element C, we call a cofactor of 3 and 3. Okay. We hide element in row 3 and column 3. So, you can see clearly here now what's left here is 1, 2, 3, 2. Okay. 1, 2, 3, 2. Okay, then 1 times 2 minus 2 times 3. Okay, so here is 2 and 2 times 3 equal to 6. So 2 minus 6 equal to negative 4. Now, class, This is the cofactor for each of the coordinate of this matrix. Okay, -3, 0, 1, 2, 5, and -4. Okay, then this is it. 2, -5, 1, -3, 0, 1, 2, 5, -4. 2, -5, 1, -3, 0, 1, 2, 5, -4. Now, what is the definition of adjoint just now? It's a, we call C transpose, or transpose of the cofactor. So then, adjoint of A equal to C transpose, which is, we change the row 1 become column 1. Okay, for example, 2, -5, 1, 2, -5, 1. Second row, we turn it into second column, -3, 0, 1, -3, 0, 1. And 2, 5, -4 become third column, 2, 5, -4. So let's double check. What is the row number 1 here now? Row 1, 2, -3, 2. Just now is a column 1, 2, -3, 2. -5, 0, 5. Just now is a column 2, -5, 0, 5. So transpose is an interchange between column and row. Row turning into column and column turning into row. Okay. So then example 2, find the adjoint of P. Okay. So this is it. Okay. So then I simplified all this. Okay. Just now in the first example, I'll explain to you when we hide first row and first row and first column, hide first row, second column, hide first row, third column, then we get the list all one by one. Now, this is we call in this example, I give you a picture of this. Okay, now just find out -10 times 3 equal to 30 minus 5 times 3 equal to 15. So then, what is the value of the cofactor of this? Class, 30 minus 15 is 15, right? There you go. Then, next. Okay, I think I'm going to use the different colors here. Okay, 10 times 3 equal to 30, minus 5 times 3 equal to 15, 30 minus 15, 15. Oh, sorry. Okay. Okay, what about this one here now? 2 times 3 equal to 6. 5 times 1 equal to 5. 6 minus 5 equal to 1. And don't forget we got -1 here. So it is -1. Then 2 times 3 equal to 6 minus 10 times 1 equal to 10. So 6 minus 10, -4. Okay, then here now, 2 times 3 equal to 6 minus 2 times 3 equal to 6, 0. So negative, still 0 then. Okay. 1 times 3 equal to 3 minus 2 times 1 equal to 2. 3 minus 2 equal to 1. Okay, 1 times 3 equal to 3 minus 2 times 1 equal to to 3 minus 2 equal to 1 with a negative here, then the cofactor here is negative 1. Then 2 times 5 equal to 10 minus 2 times 10 equal to 20. 2 times 5, 10 minus 2 times 10, 20. 10 minus 20, negative 10. And then 1 times 5 equal to 5 minus 2 times 2 equal to 4. Then 1. Multiply with negative here, then we get negative 1. And then 1 times 10 equal to 10 minus 2 times 2 equal to 4. 10 minus 4 equal to 6. So then now, these are the cofactor of the matrix of P. Okay, now. Okay, hi, Nicole. Sorry. I do hope that you all understood the process of this. We hide for cofactor of 2, 2. Then we hide the element in row 2 and column 2. Then we get 1, 2, 1, 3. 1, 2, 1, 3. Okay. Then we get negative 10. Okay, from here we got negative 1. Then 6. So this is your cofactor of the matrix of P. So then the adjoint of P is the transpose of this cofactor, which is first row 15, negative 1, negative 4, turn it into column 1, 15, negative 1, negative 4. Then second row, turn it into second column, 0, 1, negative 1. And third row, turn it into third column, negative 10, negative 1, and 6. There you go. Okay, that's it. Adjoint of P, okay, I mentioned it just now, adjoint of P here. No, adjoint of P is a transpose of cofactor. Just now, that's this one here. Then, there are 3 methods to obtain the inverse of a matrices, adjoint, as mentioned, as we discussed just now. Okay, the adjoint, we discussed earlier, the adjoint of A, to find the inverse using 1 over determinant multiplied with adjoint. Then use the properties of AB equal to KI and the elementary row operation. Find inverse using adjoint method. Okay, now, class, this is not, as we discussed on algebra or other, we call the topic we previously, A power of negative 1 is 1 over A. It's not applied for matrices. Okay, it's different. The inverse, which is 1 over determinant multiplied with the adjoint of A. Okay. So it's make sure that A is a non-singular matrices and inverse matrix exists. Okay. If A with the determinant of A it's not equal to 0. If it is equal to 0, then A is a singular matrix and the inverse does not exist. Example 3. Okay, I'm not to discuss spend my longer time on this. We call matrices of A because it's a size of 2 times 2. So we just look at it. Okay, determinant with AD minus BC. 3 times 4 equal to 12 minus 1 times 5. Then 12 minus 5 equal to 7. Okay, the adjoint. Adjoint here. Okay, then the inverse, there you go, 1 over 7 multiplied with every single element that we have of this adjoint. Now, example for 3 times 3. So we're going to focus on this here now. Find the inverse of matrix of B. So determinant of B. Okay, class. Determinant of B. The element of A, I, J. For example, A11 multiplied with cofactor of 1, 1. Okay. Plus and minus. Okay, which I think that we're going to look at example here. Okay, for example, we got element in row 1. Okay, 1 multiplied with we hide element in row 1 and column 1. So we can see here now 2 to negative 1, 10. 2 to negative 1. No, 0. Sorry. Okay. And then minus 3. Okay. Minus 3. And then these 3 we call lines in row number 1 and column 2. So what I see here now, we can have is 0 to negative 2, 0. 0 to negative 2, 0. Okay. Plus with hide element in row 1 and column 3. So I can see here now is that 0 to negative 2, 1. Okay. So from 2 here, then the minor 0 to negative 2, 1, 0 to negative 2, 1. Okay. So now 1, 2 times 0 equal to 0 minus 2 times negative 1. Minus 3, 0 times 0, minus 2 times negative 2. Plus with 2, okay, 0 times 1, minus 2 times negative 2. Okay, so this is 0, 0, and 0. So 0, negative times negative become positive. Negative, negative become positive. So 0 plus 2 equal to 2. Okay. Negative times negative become positive. So 0 plus 2 times 2 equal to 4. So 0 plus 4 equal to 4. 4 times negative 3 minus 12. And here, a negative times negative then become positive. So 0 plus 2, 2 times 2 equal to 4. So 0 plus 4 equal to 4. 4 times 2 equal to 8. So 8 plus 2 equal to 10. Minus 12 equal to negative 2. Okay. Get it? Okay, follow the step one by one slowly, because this is recall this video. You may recall, watch whenever you are free and reverse, forward, pause, and everything until you get the step. Okay, now this is the determinant. So then alternative method, or the other method, I think we still remember this: multiply this and this. Okay. Here and also here, minus this one here. Okay. Okay, so 1 times 2 times 0 plus 3 times 2 times negative 2, and then plus with 2 times 0 times negative 1. And minus every single, the one that we multiply with the arrow from bottom to the top here. Okay, negative 2 times 2 times 2 minus negative 1 times 2 times 1. And minus 0 times 0 times 3. Okay. So this is 0, 0, 0. 3 times 2 equal to 6, times 2 equal to 12, negative, negative 12. Okay. Minus negative 2 times 2 equal to 4, times 2 equal to 8 with negative, negative, negative become positive 8. Then negative, negative, then positive. 1 times 2 equal to 2. So then 8 plus 2 equal to 10. So negative 12 plus 10, negative 2. Yeah, it's still the same. Okay. So now class. Okay. Cofactor. Okay, so 2 times 0. 2 times 0 equal to 0 minus 2 times negative 1 equal to negative 2. So 0 plus 2 equal to 2. Okay. 0 minus 2 times negative 2. 2 times negative 2, negative 4. So 0 plus 4 equal to 4 with negative, so then negative 4 here. Then 0 times negative 1 equal to 0 minus 2 times negative 2, negative 4. So 0 plus 4 equal to 4. 3 times 0 equal to 0 minus 2 times negative 1 equal to negative 2. So 0 plus 2 equal to 2 times with negative, negative 2. 1 times 0 equal to 0 minus 2 times negative 2, negative 4. So 0 plus 4 equal to 4. 1 times negative 1 equal to negative 1 minus 3 times negative 2 equal to negative 6. So positive here, negative 1 plus 6 equal to 5, and negative here, so then negative 5. Okay, so 3 times 2 equal to 6, minus 2 times 2 equal to 4. 6 minus 4 equal to 2. 1 times 2 equal to 2 minus 0, then 2 with negative here, so then negative 2. Okay. Then next, 1 times 2 equal to 2 minus 3 times 0 equal to 0. So we got 2 here. Okay, so then cofactor of B, 2, negative 4, and 4. Let's say if I erase everything here, there you go. This is the cofactor of B. Get it? Okay, 2, negative 4, 4, negative 2, 4, 5, 2, negative 2, 2. So then, cofactor of B, 2, negative 4, and 4. 2, negative 4, and 4. Negative 2, 4, negative 5. Wait. Negative 2, 4, negative 5. And 2, negative 2, 2. 2, negative 2, and 2. This is the cofactor. Then the adjoint, it is this one, the cofactor of B transpose. Okay, which is turn it the first row into the first column, that we get 2, negative 4, and 4, negative 2, 4, negative 5, and then 2, negative 2, and 2. There you go. So now, adjoin. This is it. And finally, it is a negative half times 2, non-negative 1, negative 2 times negative half, 1 and negative 1. This one, negative to positive, 4 divided by half, 4 divided by 2 equal to 2, negative 2, 1, negative 2, 5 over 2, and negative 1. This is it. Okay, the inverse of matrix of B. So the properties of matrices, okay, which I think that please recall. Remember all this inverse, and we call the properties of inverse for matrices. Okay, now, if matrix of A, we just focusing on we call the matrix of 3 times 3. Matrix of A times B equal to B and A, and the result of this is a matrix of identity. Identity 1 0 0 0 1 0 0 0 1. Okay, this is a matrix of identity. So the multiplication of two matrices, if even A multiplied with B or B multiplied with A, and it gives you the result of matrix of identity like this one here. So we come up with conclusion that B is the inverse of the B equal to the A inverse. So then A multiplied with A inverse or equal to the matrix of I. Okay, and then if A multiplied with B equal to any constant multiplied with I, for example, we got 3 0 0 0 3 0 0 0 3. Then take out all the 3 here. 1 0 0 0 0 1 0 0 0 1. So then this is the 3i. So 3, okay, represent the alpha that we see in the screen here now. It is 3 multiplied with the identity. Okay, also B inverse equal to 1 over alpha times with the A matrix of A. Okay, if A, B equal to I, when A and B are square matrices, then B is called the inverse of A and written as A inverse. Thus then, this one here. There you go. Find inverse of using property of A, B equal to Ki. Okay, class. For this one here now, we multiply every single element in the first row. First in the we call in the element in the first column 1 times 1. Okay, 1 times 1 plus with 2 times negative 10 plus with 3 times 7. Then multiply with element in second row. 1 times 1 plus with 2 times 4 and 3 times negative 3. Next is 1 element in row first row multiply element in the third column here. 1 times negative 1 plus with 2 times 2 plus with 3 times negative 1. Okay, there you go. Then next, element in second row multiply with element in the every single column that we have here, which is 2 plus 3 plus 4. Okay, and here is 2 plus 3 plus 4, and then 2 times negative 1 plus 3 times 3, 2, and then 4 times negative 1. Then next, element in third row with every single element in the first, second, and third column, just the previous step just now. So then 1 times 1 plus 5, 10, negative 10, plus with 7 times 7, and then 1 times 1 plus 5 times 4 plus 7 times negative 3. Okay, and then 1 times negative 1 plus with 5 times 2, and then 7 times negative 1. There you go. So we can list down all one by one. This is negative 20. This is 21. So negative 20 minus 21 minus 20 equal to 1 plus 1 equal to 2. Okay. 8, negative 9. 8 minus 9, negative 1 plus 1 equal to 0. 3 times negative 1 equal to negative 3. 4, okay, 4 and then negative 1. So then negative 1 minus 3, negative 4 plus 4 equal to 0. So, okay, this one is negative 30, 28, and 2. 28 plus 2 equal to 30, minus 30 equal to 0, then negative 12, 12. 12 minus 12, 0, plus 2 equal to 2, and this one here, negative 4, 6, and negative 2. Negative 2 minus 4, negative 6, plus 6 equal to 0. Well, I think that you can guess what we last here is 0, 0, 2. So, class, take out all the 2 here, and then 1, 0, 0, 0, 1, 0, 0, 0, 1, which is now become 2i. Okay, so the constant of alpha in the previous slide is represented by 2 here. So AB equal to this one here. Okay, so the constant of K equal to 2. Then, so A inverse equal to 1 over 2 times matrix of B. Okay, so this is the step to explain it. Okay, A inverse multiplied with AB equal to this one here. So then, class, A inverse multiplied with its matrix equal to an identity. So this one here come up with identity of B, and any matrices, okay, inverse, we call identity inverse of matrices no, not inverse, this is identity. Any matrix of identity multiplied with any matrices equal to B. Okay, so then A inverse equal to 1 over 2 B here. Okay, example 6. Okay, so then we list down all here. Okay, class, for this question, I'll choose the easiest one. Okay, I'll choose, let's say, 1 times 1 okay, class, to make it short, you recall multiply this matrix of A with A, these two, okay, so I make it short here. It's gonna give us 11, 7, 7, 7, 11, 7, 7, 7, and 11, plus with M 3, 1, 1, 1, 3, 1, 1, 1, 3, plus with N with a matrix of identity 1, 0, 0, 0, 1, 0, 0, 0, 1 equal to the matrices of 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so now to find the value of m and n. Okay, so class multiplication of a is a square, or multiplication between matrix of a and a here. You try by yourself, and this is the result. So now if I choose 7 plus m, okay, take this m multiplied with 1. Okay, 7 plus n times 1 plus with n times 0, which is 0, okay, equal to the third element here is 0. So that, okay, m equal to negative 7. And if I choose 11 here plus with 3 times m, 3m plus with 1 times n equal to 0. Okay, so just now m equal to negative 7. Okay, so then 11 plus 3 times negative 7 plus n, this one 0, equal to 0. 3 times negative 7 equal to negative 21. So 11 minus 21, n equal to 0, then n equal to no. It is, okay, 11 plus 3 times negative 7 minus 21 plus n equal to 0, so then n equal to 10. Okay, so m negative 7 and n equal to 10. So now from here, okay, class, from here we can come up also with a square equal to negative 7a bring to the side become positive, so then 7a and negative 10i bring to the side become negative minus 10i. Okay, so then multiply both sides with the a inverse here, just like this. Okay, a square means that a multiplied with a inverse. So this one will turn it into an identity. Okay, and then a multiplied with a inverse, then also another identity. And this one here, 10i multiplied with a inverse. So then a inverse equal to, this one equal, as you see the screen here now, divide by 10. 1 over 10 multiplied with 7i minus a. Okay, so then next, a cubed equal to a square multiplied with a. Just now, we look at this one here. A square equal to 7a minus 10i. A square equal to 7a minus 10i. A square equal to 7a minus 10i. Okay, so then replace or substitute a square with this equation here. 7a minus 10i multiplied with a. There you go. Okay, then, and a square itself, a square with 7a minus 10i. Then, okay, that's it. Okay, so these all things you play with all the equation just to recall, simplify and find the answer for the question. Okay, so that's it. I do hope that all of you understood, and if you find that this explanation or this subtopic or this part is very difficult, then bring up this matter in our what we call official lecture hour. Okay, that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.